So, now we were discussing till now kinematics, and in kinematics we were discussing motion in a straight line. Now, we have to do next concept, that is relative motion in one dimension. So, the motion we will be taking only a straight line, but here we are going to study relative position. See here, relative motion. What is this relative motion actually? What does it mean? Suppose you have got one body over here, that is body A, and here is another body B. Both are moving in the same direction with the certain speed, suppose VA and VB. Suppose VB is greater than VA, so the separation between them keeps on increasing. Suppose VA is greater than VB, so separation will keep on reducing, and a time will come when the VA will overtake B. Time may come, and now the A will be ahead. Similarly, if the VA and VB both are equal, and this separation will remain constant. So, we call it here, if you are taking relative velocity of B with respect to A, so we can say relative position of B with respect to A. If you are discussing relative velocity of A with respect to B, so you can say relative position of A with respect to B. So, actually here we will define term that is called relative velocity. So, now see here in relative velocity, what do you mean by the relative velocity? Relative velocity actually defined as the time rate of change of relative position of one object with respect to another object, as we have discussed in the previous example. For calculating relative velocity, suppose if you are writing relative velocity of A with respect to B, it means velocity of A if B is supposed to be stationary. It is the meaning of actually the relative velocity. And also in relative velocity, we include frame of reference. Suppose if I say a car is traveling at a speed of 60 km per hour. What does it mean? It means actually the velocity of the car with respect to earth, because earth is at rest here. Similarly, the velocity of car with respect to B. So, here you are observing velocity of A from the B, or you can observe the velocity of car B from the A. So, all this study or study of relative position, the time rate of change of relative position is referred as relative velocity. So, now see here, we will take example here. Suppose you have taken this point is here, I am taking this is as a origin here. Just I am taking here the two lines. Here is one car, suppose A, which is going with the velocity VA. I have taken this is the point origin from where we are studying the motion. This position we can take initial position is x naught 1. Similarly, the body B is over here and it is moving with velocity B, and its relative position from origin is taken, sorry, position with respect to origin is taken x naught 2. Both are moving with the speeds VA and VB respectively. At t is equal to 0, they are here, this is here, this is here. Now, after any time t, you can write their positions. So, after time t, you can write the position of the body A. x1 is equal to x naught 1 plus VA into t. Similarly, you can write position of B after t time, after t seconds. So, x2 is equal to x naught 2 plus VB into t. This is the final position at time t1 x1, and this is the final position x2 for the body B at time t. Now, if you subtract these two, suppose if you are subtracting these two, so you will be getting x1 minus x2 is equal to x naught 1 minus x naught 2 plus V A minus VB into t. So, this is the displacement, you can say relative position of object 1 with respect to 2. This is the initial relative positions. So, obviously, this will be referring for the relative velocity. But so here we can also write down here the displacement is equal to x naught 1 minus x naught 2 plus V A minus V B into T minus x naught 1 minus x naught 2. This is the final relative position and this is initial relative position, that is called relative displacement. So, we can say here relative displacement, these two will get cancelled. So, you will be getting here V A minus V B into T. Now, so relative velocity we can write, relative velocity is equal to V A minus V B into T divided by time interval T. So, this we can write here V A minus V B. This is here we write as V A B. It is here actually relative velocity of A with respect to B. So, the relative velocity we can calculate by this way, this is the method for that. Now, you can do some graphical study for that in the same thing. Suppose you have taken a graph like this and here you are taking position x in this side, time in this side. You are drawing graph in this manner here. This is A x naught 1 and this is here we have taken B x naught 2. Now, see here what you can say in this case. In this case, initially these are representing actually initial position with respect to origin. This is the relative displacement between the two bodies initially. Now, these two graphs are parallel, it means between these two bodies relative position or relative displacement does not change. That means obviously V A is equal to V B. So, this has got velocity V A, this has got velocity V B. So, you can write here V A is equal to V B. It means both the bodies are moving with the same speed and the relative position between them remains constant with the time. Now, go for the another example here. Similar graph we can take for the another case. Suppose you are taking like this is here x and here we can take like this is x naught 1, this is A and here we can take like this x naught 2. Now, see what can you conclude from this graph? Initially they are starting from here, but with the time the gap between them is increasing. So, what will happen here? This is your V A, this is V B. So, we can we say your V A is greater than V B. So, just by seeing the graph you can conclude V A is greater than V B. Now, if I draw the same graph in the different way like this, here I have taken x and t, it is like this x naught 1 A and here is x naught 2 and we can write like this is V B, this we can take as B. Now, what you can say about these two graphs? Obviously, V B is greater than V A and this is the point when V B is actually when the body B is overtaking body A. So, these are the graphs for studying this relative position or the relative velocity. But for studying relative velocity, it is necessary, see here, you have to make one object at rest, then you have to study the velocity of another object with respect to that object. So, now we will see how a determination of relative velocities in the different cases when the bodies are moving in the same direction or when the bodies are moving in opposite directions.